Hello, good afternoon. Thank you for attending this session. So I'm working for Intel, and I'm from the Asia Pacific Development Center based in Shanghai. I have been working on big data security for several years, and so today I would like to share our experiences and our work that in big data security. And specifically in this session, we will cover majorly focus on data encryption. So security is a very comprehensive aspect of the have many aspects of security, and today, so I will my focus is data encryption aspects, and of course I will covering some related topics such as authentication sampling, and then we will introduction some basics about the aspect of the Hadoop and the Spark, and we will share what our work, and we will have a deep dive into the performance security, so that this can help you to make decisions when you considering the performance problems of deploying big data solutions. Okay, so the challenges of the big data security. Security is everywhere, and traditionally, a lot of security technologies still applicable for big data, but it still has some specific challenges in the big data environment, like Hadoop and Spark. And first, we do see that the big data environment is a highly distributed system, and this actually complex the security management and also the data encryption themes. And another characteristic of big data is that it is extensive data sharing across different function components. We can see that we may store data in HDFS, and we also store data in the S3, for example, in cloud. But this data is accessed from various components, such as you may using Hive for SQL, and you may use Spark SQL and any other machine learning components, and you will have high-level stacks for visualizing your data. So all this data is shared in a loosened way, that in a very comprehensive environment. So this put a lot of challenges that to management your secure environment of big data deployment. And finally, that is related to performance. We know that big data is related to volume of the data, and you need to processing any kind of a large amount of data. And if we do apply security mechanisms to this environment, is, for example, data encryption, and we may consider in the major problem of that whether the performance issues. So these are all the challenges of the big data security. And let's see some security aspects that we may consider in a big data security environment. And the first is the authentication. You know that every security mechanism is based on authentication. If we don't have authentication and we don't have any root point that to make any decision points, such as authorization, or even that you do data encryption, and then you need to do key management, and how you manage the key to authenticate the user, the right user to have the right access rights to the right key. And the second is the authorization. So once a user is identified and its identity is identified, then we usually make authorization decisions which control the access of different data to this user. And also, even for data encryption, we still need authorization, that you need using authorization to control the key management system so that the right user has the right key access privileges. And finally, that the confidentiality of the data. Even that you have authentication and you have the right authorization policies there, that doesn't mean that you don't have to protect your data by encrypting your data. Such as if, for example, if you store data in the disk, and in the big data environment, and your disk is when a node is down and is malfunction, you may remove the disk. And then if the data keep plain text in the disk, and you have to be very careful for your disk disposal process. And then if the data is encrypted on the disk, and so you don't worry about as long as your key is protected in your system and is not leaked. And finally, usually we consider that the traceability of the system as one of the final security aspects, that you need to tracking the access of the data, the access pattern of the data, and whether there is a violation of access privileges. And this can help you to make decisions actively, other than you have to wait the instance to happen and then you take actions. So this is a very simple brief of the big data security aspects. And let's come to our topic of protecting data. And protecting data has two aspects. And one aspect is that we need to protecting the data at motion. In a very distributed environment, your data is transferring across the network between the different nodes. And this network, the data transferring to the network, if not protected, it's very, very easy to be leaked by spoofing the network. And we can see in the Hadoop and the Spark environment, we have several aspects of data at motion. First, you do RPC communications for interaction between user and the server process, and also between the server process. And the data transfer actually is one form of RPC communication, but sometimes it is more important related to your real data other than your request or command, so which is more important. And it is usually in larger amount of data, your RPC request may be more small, but data transfer is a large chunk, and which is more performance sensitive. And finally, we know that the big data environment using a lot of techniques of shuffling data, such as Spark and MapReduce. If you're running a job and the data is shuffling across the different nodes when running a job, which is has group by or join such features. And finally, the second aspect is that the data at rest. And for example, if you store data in the storage system, and then your data needs to be encrypted, sensitive data needs to be encrypted. For example, if you store HDFS data at HDFS, and sometimes when you're running a job, your data will be spilled out when the memory is not enough, such as when you are running a Spark job, and then the data is spilled to your local disk. And then if you don't protecting such data for sensitive data, then there's still some possibility of data leak. Okay, and finally, let's come to some background of understanding Hadoop tokens, and this will give us allow us to understanding the reasons that and the problems of existing Hadoop and Spark problems. And first, we can see that in the Hadoop environment, the only secure way to secure your Hadoop system is that you use Kerberos authentication. And Kerberos is a widely deployment in enterprise systems, and it is convenient for user authentication, but actually it is not has some problems, and it is not convenient for authentication between processes. So Hadoop and Spark are distributed environments, and you not only needs to authenticate the user, but also needs to authenticate the process that connected to the servers as a whole system. Otherwise, actually, some other bad process can fake their some bad process can do bad things in the system. Okay. And then we can see that So Commons token is usually used as the front-end user authentication. And in the Hadoop environment, the delegation token is widely used for performance reasons and also as well as performance reasons. Usually, user is authentication through the corpus, and then it can exchange a delegation token through the server process. And afterwards, when your tasks are accessing data, it will use delegation token to access all your data and other services. So we can see that a corpus token can exchange to a delegation token, and then a delegation token, both a corpus token and delegation token, and can be used to exchange some other tokens like block token, which is in HDFS management the data access privileges, and then also job token for example if you're running jobs in YARN. So we can see that in the Hadoop distributed Hadoop system, and delegation token is widely used as inter-process communication authentication mechanisms. So the problem of this is that the delegation token internally use SASL digest demystify mechanism, which is the mechanism that delegation token using. But this mechanism is using 3DS algorithms, which is quite slow. So this is the problem of the current the Hadoop implementation of secure layer to do encryption, and then to solve this problem, and we did a lot of work in the community, and first is the HDFS. HDFS. So first the first feature is that we provide a feature to optimize the data encryption when HDFS transferring data between different data nodes and between user and the data nodes, so that even that you enabled data encryption, but your performance will not impact. And later we will visit the performance secret and how we can achieve that. And first, let me go simply through of these features. And these are a list of data at motion encryptions features. And then for Spark, we implement the Spark shuffle file encryption, which means that when you are running a Spark job, your data is shuffling across the network, and then we implemented this feature so that you can encrypt all the shuffle data across the network and as well as that when the data is speared into disk, and we can encrypt it. And the second feature that we do for Spark is RPC encryption, which can enable you to encrypt all the RPC data without performance impact. And finally, we have edge-based RPC encryption optimization. So all this work are done in the community upstream, so everybody can use that. Okay, we have a very simple view of one of its features, that the Spark Shuffle data encryption. We know that we may usually see this picture, and this is a very simple Spark Shuffle, two stages shuffling data between each other, and there are two places. And the first is that the stage one side, and when the memory is not enough, it will spear data to disk. So this is the place that we need to encrypt the data when it is speared to the disk. And the second is that you will transferring data across the network, and then we need to encrypt the data when you're transferring data across the network. So the Spark Shuffle file encryption, that you know that the origin. So this is a very simple instruction to the shuffle file encryption, and the problem of that the Spark original didn't have the encryption capability of spilled files. And the second is that Spark has the encryption capabilities of data shuffling across the network, but just as mentioned previously, it used 3DS as the encryption algorithm, which is quite slow, and if you enable it, and the performance will be greatly impacted. So our work is to enable these features and optimize with AES-NI. Later we will visit the performance characteristic of AES-NI. And here is the work we did in the community related to data at rest encryption. And first is the HDFS. And Intel collaborate with Cloudera and implement this feature and to protecting your data that is stored in the HDFS. And you can configure a specific folder to be encrypted, and so that every file read into the folder can be encrypted automatically. And when your task is reading that part of data, it can be decrypted automatically as long as the user submit the job has the right right privileges to access the key. And the second is the S-based transparent encryption. So, and this feature will encrypt the H-based table at the server side. The final thing that I can actually we have already mentioned that to encrypt the spilled data at rest. Let's have a very simple view of the data, HDFS data at rest encryption. And so the concept is that there is a security zone, and you can set up a folder as a security zone. So each security zone will, so we can go through the create file process, a rating process to a security zone. If you set up a security zone and read a file to a security zone, you make a create request to the NAND node, and the NAND node will contact to the KMS for generating a random key and encrypt with the security zone master key and return to the NAND node. And the NAND node will put encrypted data key into the NAND space, which is stored in the NAND node, and then at the same time, it will return the encrypted data key to the user. And at this time, the user will have to access the KMS because he has only an encrypted data key. So he has to decrypt the data key, and then the KMS will authenticate the user, and as long as the user has the privilege, then the KMS is the key management system, so it will return the key to the client, and the client can write data and encrypt the data and then write to the data node. So this is a very straightforward process for write file, and then we can go through a very simple process for reading a file. The client will make an open request to the NAND node, and the NAND node, because NAND node has stored the encrypted data key, and it will return the encrypted key to the end user. The client will, just as previously, it will use the encrypted key and make a request to KMS, and the KMS will return a decrypted data key so that the user can then read in data through the data node and decrypt locally when it running the tasks. Okay, so let's come to the final parts of the performance secrets. So previously we know that the 3DS is very slow, and how we can achieve that. First, we replace the 3DS into AES. We also know that AES is the national standard and is widely used by a lot of applications. It's secure and high performance. But the software implementation of AES is still slow when we are using encryption in an in-memory environment such as Spark. So we use the two techniques. First is the hardware accelerated encryption using AES-NI. AES-NI is instructions, and the second we use instruction pipelining, and we will later explain some details of this to help you understand. First, let's introduce AES-NI. AES-NI is a new instruction set, an extension to IA instruction architecture for microprocessors since 2008. Actually, it's a very old instruction set, but actually if the developers are not in the secure area, they are not very familiar with these instructions. And it supports, so most of the Xeon servers in our data center should already be supported this instruction set. So and it has 7 new instructions. These instructions will this instruction acts in the Xeon processors, and it can provide high performance of encryption of AES. And so let's to help you understand how the AES-NI is working, let's have a simple view of AES algorithm. In high level, AES algorithm is very simple. And let's ignore the different lengths of the key, and we can see that for a data key, there is a key expansion process, and it will expand the different round key. For example, a 10 round key, and then you have the data block. And the data block will be exclusive OR with the round 0 key, and generate a state 0. And then there will be several rounds with each round key and generate an intermediate state, and finally the last state is the result. So this is the overall, actually is a loop of doing a process. And we can see in the rectangle in the bottom that demonstrate that each round, the work that each round it is doing. So this is a very complex mathematics and vector mathematics, but let's ignore that. So what AES-NI do is to implement each round using a single instruction. For example, it uses AES-ENC of all the work that is done in a single round. So the user program the only work that the user program do is to combine all this round using a single instruction. So we can see that 4 to 5 times performance improvement using a single instruction for the AES-N round, and comparing to the software implementations. And the second secret that instruction pipelining, just as we previously see that there are multiple rounds, and process actually have a pipelining of modern processors have a design of instruction pipeline. We can see in the left picture, and the first the picture above shows that a single data block that runs multiple rounds. We can see that there is, for example, 10 rounds, run multiple rounds to generate the final encrypted result. And then if we don't pipeline, we can see that in designated CPU cycles, and we have a very low data throughput. But by using instruction pipelining, actually we can issue multiple data blocks for different rounds. But we cannot, for a single data block, we cannot pipeline it because each next round depends on the result of the previous round, and then for a single data block, it cannot the instruction or it cannot pipeline it because of the dependency. And the technique here we did is to issue multiple data for the same round, and so that they don't have dependency, and then the instruction of the different data block can be pipelining. And we can see that by using these techniques, we can improve the performance by 4 to 5 times. And when we add these two techniques up, and we can achieve 10 to 15 times of performance improvement comparing to the pure software implementation of AES algorithm. Okay, how about JDK? So we may wonder that we can simply use JDK to achieve the performance, and we do see some purpose in JDK. So for JDK 7, if you are using JDK 7 and the JDK 7 hotspot intrinsic actually is using AES. It is using AES, but it doesn't optimize for instruction pipelining. So which means that the JDK 7 still has 4 or 5 times performance slower than the most optimized implementation. And then we contribute this optimization to JDK 9. You can refer the link as to the patches. And, but we know that JDK 9 will be released in the middle of this year. And we also know that a new JDK will have a slower adoption in the enterprises area. So we do see that even that with the optimization in the JDK 9, so we do still need some other ways to optimize our big data platform. And once the JDK 9 becomes to the mainstream of the deployment, I think the JDK 9 can provide the best performance of this by utilizing the AES-NI instruction and instruction pipelining. Okay, so what are the other options before JDK 9? So first, you can using OpenSSL for C and C++ developers. OpenSSL actually is the most optimized with the techniques just mentioned before, and if you are developer using C or C++. And then you can also use SASL crypto library, which is hosted in the Intel development library that implemented the crypto algorithms and in the method as I mentioned. And finally, last year we contribute this work in the Apache Commons crypto for Java and Scala developers. If you are using Java and Scala, and then you can using Apache Commons crypto, which you don't have to care about the native cores. So we wrap the JNI for you and provide the best performance and the right API like Java. So it is also maintained at Apache Foundation. So this is most the big data Hadoop and Spark projects maintaining. Okay, so this is what mostly my introduction. So finally, we can any questions? Hi.
Were there any improvements made between JDK 7 and JDK 8? Because JDK 8 has seen some kind of adoption now. Were there any improvements from JDK 7 to JDK 8?
7 to 8 actually. Just we mean in the 7, Java actually has so the question is that is there any enhancement in between JDK 7 to JDK 8? Okay, so as to the JDK 7 has a lot of upgrades, and JDK 8 also has upgrades. So the AES instruction was getting to JDK 7 upgrade 45, and after that, between the JDK 9, after that, even in the JDK 8, there is no improvement related to this area. So so our new work is that in the JDK 9, we did the optimizations into its trunk. Thank you. Any other questions? No, thank you. Thank you.